Kirchhoff's voltage law states that all voltage must be used up in a complete closed circuit. This circuit is the first of 3 of my circuits demonstrating Kirchhoff's voltage law. This circuit is made up of 3 passive components: a 1 k ohm resistor, a 470 ohm resistor, and a 2.2 k ohm resistor. The 1 k ohm resistor uses 2.4 volts, the 470 k ohm resistor takes 1.4 volts, and the 2.2 k ohm resistor takes 5.2 volts. This circuit, being made up of 3 passive components, shares the voltage between the 3 of them based on their resistance. The higher resistance resistors take more voltage, and the lower resistance resistors take less voltage. For my second circuit, there are 2 passive components and 1 active component. The 2 passive components are a diode and a 470 ohm resistor. The diode stops the flow from returning into the positive lead, and the resistor stops the LED from blowing. The LED, being an active component, takes the amount of voltage it wants, this being 2.8 volts, and the 470 ohm resistor takes the remaining 5.2 volts. Any leftover from this was taken up by the diode, being about 0.7 volts. For my final circuit, there are 2 active components and 1 passive component. The passive component is a 10 k ohm resistor, which takes 4.6 volts, which is the leftovers from the 2 active components, which take the voltage they want and leave the rest for the resistor. The green LED takes 2.3 volts, and the red LED takes 1.8 volts. From all 3 of these circuits made up of active and passive components, the active components take their voltage and leave the rest to the resistors and other passive components before heading into ground at 0 volts.